Greetings, Augies. I'm Dave Kassler, amateur radio call sign KE0OG, and we are gathered here today for Ask Dave number 120. I've been asked, and I'm sure you've asked the question too, given the expense of Morse code keys and so on, is there some inexpensive way to build a code practice oscillator so you can get your code speed up? And the answer is yes. This was sent to me by the 4 States QRP group, and it's a kit. And here's what's in the kit. There's a little circuit board, okay, and it's got the key or Morse code right here. There are 2 mistakes in there. We'll talk about those later. And it's a very, very simple thing to build. As you can see, 2 transistors, some components here and here, a battery, and a key. Okay. Now the first thing that we have to do on this is get the manual. We need to print that out. The kit comes without a manual of any kind, nor is there a piece of paper in there telling you where to go get the manual. So let's go find it. It's on the 4 States QRP page. Okay, here's the manual, hot off the printer. It's 4 pages, which I've printed onto 2. Now it'd be easy to say, because they're just 2 pages, I won't bother stapling them, but the thing is, there's no page numbers, okay? And it's real easy to flip a page over, do the wrong thing with it. So let's just get this all together here. Now, the reason to print the manual is because there is a checklist for the parts and checklist steps for the assembly, just like one of the old Heathkit manuals. So I think it's imperative that you go ahead and print the manual so that you can check things off. All right, we've got all the supplies we need. We've got Phillips screwdriver, diagonal cutters, soldering iron, and solder sandpaper or emery board. That's an extra step in there you can do without, and a 9-volt battery. I think I have one somewhere. Now we're going to check and make sure that we have all of the parts. There's 2 bags here. This little bag, which looks like a little snack bag, has got a dinky little tiny speaker in there. Almost just looks like a piece of plastic, which is what it is. It says 8 ohms, half watt is what it can handle. Okay, so let's check these off. The problem with staples getting on the carpet is you can be walking in your ham shack and barefoot and step on one, and that's not generally considered pleasant. Okay. We've got lots of little things here. Let's pick out see if we can pick them out in order. That speaker, I'll just move that over here so we can move these things over here. Okay, 2 capacitors. We've already checked in the speaker, and we've got 0.1 microfarads PC board 104. It says this edge on it over here. This edge is designed to break off. Don't lose it, because it's the key. Okay, let's just push this stuff just slightly out of sight here. Okay, and we'll go down here. First, take the PC board and snap off the section at the right side of the board. Well, that assumes now that you're handling this with all the text in normal direction. Do it carefully and slowly. There. You see it'll kind of give, and then you come back. There are somewhat slightly sharp edges. That took care of it. Just rubbed it on the edge of the desk. Okay, this is the key. We'll use that in a minute. Okay, having done that, and used our equivalent. The very first thing that we need to do now is mount the speaker. Flip the board so that the component side is down. Okay. Take the four 632 by quarter screws and insert them place the speaker in the middle of them with the two tabs for the connections right by these, because that's where they're going to be connected. Now we're going to take four of these. How are you?
Okay. Toys everywhere.
Yes.
It's windy out there.
Is it really?
Especially the. Oh, I see myself on the. Oh yeah. Closer you get to Montrose.
Really?
Wild.
Wow. Well, I'm recording how to make this kit here.
Oh, okay. I'm sorry.
You're welcome to be in the video. Okay, attach the nuts to the screws and finger tighten the four nuts down. Now, snug means just barely tight. Okay, you don't want them to fall off. Okay, so what we've got here is these are up the side, these are slightly over, and that's just fine. And we'll solder something in here later. Okay, so there we are, our first component installed. Now we're going to solder. Okay, low wattage, 20 to 30 watt pencil type soldering iron be used. Only rosin core solder may be used, as acid core plumber's solder will corrode the components and boards. Okay, soldering is not hard if the proper procedures are followed. Well, I gotta tell you, it took me a while to learn to solder. I was halfway through assembling an HW16 kit in 1975 when I finally got the soldering right. Fortunately, what was there before was... Okay, so I'm gonna get my soldering iron right here, and I've got this little thing for cleaning the soldering tip. So I'm going to turn this on. This is my soldering thing. Okay, we're not going to use the heat gun, we're going to use the soldering, so we'll turn that on. That's about the temperature in Celsius that I use. So now the iron is heating up, okay. And then, once it does that, which it will soon, I'm going to be putting this in here, like that, to get that tip clean. And you can see where it has been coated with solder. Okay, it's tinned. I used to solder with the great big stuff, and that is, let's see, it's 0.062 diameter. Alright, and then I now use this 0.32 diameter, which is a lot easier for the small board components. And obviously you can't get it from Radio Shack anymore, but it is available. Okay, so let's go through the things that it talks about. These soldering iron has reached working temperature. Now I need to get a 9-volt battery. Okay, take a 9-volt battery, hold it so that the terminals are to the left and the smaller are positive, and you can see the positive right there is the smaller one. Okay, so that's going to mate to the bigger one of the battery terminals, and then this will mate to the other. Now, a word of caution: do not, I repeat, do not short these together. Do not short these together, okay? Because if you do, you'll drain out the battery in the proper holes, okay? And we turn this over with something to kind of hold up that side. Now we have the battery terminals right here. We want to make sure that the positive one is on the top, okay? And it says positive right there. Now this is critically important, because if you do it the wrong way, not only will the project not work, but you might actually smoke some of the components. Okay, we're going to solder these. Get a little solder on the soldering iron. It helps with heat transfer. Now just, see, just a little solder. It helps with heat transfer. And I find it invaluable for my old eyes. Have that. After we are done soldering, we go like this to clean the tip of the soldering iron. Some people do it with the little yellow pad, but I like this better. Okay, take your 9-volt battery, hold it so that the terminal, smaller positive terminal, snap on the battery clip, certain the positive polarity is thing. Okay, we've inserted it. Solder the battery clips in place, then remove the battery. It's a little easier said than done. Okay, battery's out of the way now. Solder. Okay, locate the two 15K resistors, brown, green, orange. See? You just, to get them off of this, hold on kind of like this and just sort of pull that off. Okay? Put that thumbnail there and just pull it off. Don't try and unfold it or anything. You'll find that very frustrating. Okay, so these are the 15K resistors. We slide these through the holes. Now, when you put it through the hole, bend these out slightly so that it can't come through. Now, I say slightly, but if you notice, they're about a 45-degree angle there. Okay, and they won't come out. You don't want them too far over, because when you solder them, right there, you want to be able to gently clip off the excess lead material. So let's put the other in place. We'll put the two in place and then solder them so that we're following the instructions. These are called through-hole components because you push the leads through the hole and solder on the other side. Now, that begs the question, are there something different from through-hole components? The answer is absolutely yes. They're called surface mount components, where the device has a just sort of a, it doesn't have a wire lead, it has sort of a little pad kind of thing, and that's soldered right on the surface. And when you do it that way, you can have a machine do the soldering for you, and it can be very quick. And because a machine is doing it, you can make surface mount components very, very, very small. Okay, here we are with the leads. They're soldered. The soldered connections all look good. Now we're going to take our diagonal cutters. Diagonal cutters. For some reason, these are sometimes called dikes, D-Y-K-E-S. I don't know why or where that came from. And it's not so common today as it was. Hold on to the wire as you cut it off. Now the reason that you do that is twofold. One, we're going to need 2 of these. And second, if you don't, that little lead can go flying and end up who knows where. You could step on it and then it's in your foot, or it could go in somebody's eye. So gently hold on to the lead and you snip right down all the way at the base, just above that solder joint. See? All right. There. Okay. We put them in. We soldered them. Repeat with the 470 ohm resistors. Obviously, when they say repeat, they mean do them in the correct holes. Be nice. Don't cut monster things with them. Obviously, your greatest cutting force is right there, and your least is at the tips, which is why you want your tip to just absolutely meet perfectly. If they get bent or damaged, get a new one. Don't frustrate yourself. 2220. Okay, let's see where we are. Repeat. Is a very, very common NPN transistor. So that means we've got the base, the collector, and then this comes out of here with an arrow pointing outside. Okay, and so the current will flow that way and in that way in the emitter follower configuration. These are technically radio frequency switching transistors, but they're used for everything, and they're ubiquitous. They're dirt cheap. I mean, penny each, less, and they become very useful for lots of electronic projects. Now here we put this in these holes like that, and you see that the tab is up near the tab there. Push it down a little ways, but not too far. Again, bend the leads out slightly. Bend the leads out slightly, so there we go. We've got our little transistor with the leads bent out. Now the thing about soldering transistors is the transistors are more easily damaged by heat than other components, although all components are sensitive. So we want to spend as little time as possible soldering the component. Now it's going to get hot, there's nothing you can do about it. But as long as you are doing it relatively quickly, you're not going to have a problem. Now, when you snip the leads off a transistor, if you do a snip that's a snap, okay, that snap vibration can go all the way down into the device and damage it. So, especially when you're dealing with semiconductors, I mean, they're going to snap a little bit, but be just very gentle with the thing, okay? Now we have one more to do. Find the 832 by 3/8 screw, the big one, here, and tighten it to the knob. We'll just tighten it a little bit. Okay, now just slide the spacers over the other side, and then put that there. We've got our last two nuts. Tighten them. Oops. Now when we tighten them, they don't tell you this in the instructions, but you want to make that look nice and square. Okay? Now we have one thing left to do. See, we did the keys. The key's in place. Does that look familiar, like telegraph key? Yeah, it does. Now, it says take 2 of the clipped off resistor leads and solder them to the terminals on the speaker. So what we're going to do is put a little solder on there. Okay. Now we're going to use long nose pliers. The same thing that I said for this goes for the long nose pliers. By the way, these came together in a package. And I've been using them for many years. Now what we want to do is take one of those resistor wires here, okay, and put it in the needle nose pliers. And then all we have to do is melt that solder around that wire. Okay, let's do that again. Now, push these down towards these metal plates. Cut them down here. Get those little leads out of the way. You don't want them on the project board, shorting things out. Okay, let's push these down so that they touch those solder boards. And again, we want to get a little, okay, we pushed them down on the solder boards. We're going to just put a little solder there. This is like a surface mount device. See, the device and the pad are on the same side. It does not go through the hole. And there we have it. You can see that those are hooked there. Alright. By the way, I might point out that they have on here the color code information for the various devices that are used over here. Now we put back in this, let me see, solder them down. Oh, golly gee whiz, we almost forgot. Da rubber feet. And with time, this, I mean, they're just on there with tape, double-sided tape. But with time, that will get a little harder. Okay, there we go. Now that should sit flat on the table. It does, without moving around. So we installed the 4 rubber feet and then install the battery. Okay, here is the battery. Okay, so what have we got? This is a code practice oscillator so that you can practice code sending. Now, the thing about sending Morse code is that you're sending to make it understood. You're not sending it to show off how fast you can send. You're sending so that it will be understood. So if the other guy is transmitting slowly, he probably can't receive quickly. It's sort of a rule of thumb. Most people learn to send faster than they learn to receive. So they tend to jump into going quickly, and then the other station thinks, oh, this person understands the code pretty quickly and comes back. If you want people to come back to you with slow code, answer their CQ with slow code. Okay, so this would be a great adjunct to our Saturday CW course. If you have one of these, and I think they're $15, the battery it's going to cost you another couple bucks at least. You have a nice little kit, and you have the satisfaction of a kit that you made. And let's take a look at this on the back here. A is correct, B, C, D, E, F, did it, G, dotted it. Well, look at D, dotted it. Okay, G is dit. So that G is incorrect. It's dit. H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, did it. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. A period is da. People don't use periods on the air, they use double dashes. Comma, da. Question mark is wrong. It's did it. Did it. So they've got that wrong there. The slash or virgule is did, and you would use that like if you were operating in another call area or you just upgraded and had to put AE there. Now it says equal sign because that's what's usually shown on code programs for creating da. Da is a printing character known as the M dash. That's a double dash. The N dash is shorter. This is the M dash. Da. So the equal sign is what it usually shows up as computer, but that's a double dash. Now, that means double in length. Double in length, like da dash, not da equal sign. You can see how it's real hard to put this out as a single character, whereas you can put the double dash in there as this. This is an M dash. And in printing, these are connected. So it becomes a long dash. Okay? It's also used primarily simply as a thought separator rather than a period, just a thought separator. You go RST equals 599, da, name is, it's just a thought separator. Okay, very good. What have we done? This is something you can build, and I'll put the all the details for how to do this both on my website and in the text below this video on YouTube. Okay, and this is a nice adjunct to the CW course. One thing that you can do with this that may be very helpful is take some text. If you send text into a recorder and then try and read it back, you already know the text. So start at the end of the text and send the letters backwards. Okay, they won't be meaningful words or anything, but then when you go to decipher your own code, then you, because it's random, you will have long forgotten what it was that you put down. So that's one way that you can give yourself a little bit of code practice. There are some code practice software that I'll talk about on Saturday. So there you go. Something you built yourself that you can use, and the particulars on YouTube and on my website. Thanks so much for watching. This is Dave Kassler, KE0OG 73.